Starting on page 20A and 20B, we will be looking at some PM scheduling documents. Now, these documents have been designed by companies like yourself. They're in there for your perusal and your use, and as I've indicated before, you may want to consider developing your own PM documents for the PM program. Let me merely identify the documents for you. On pages 21 to 24, there's 4 pages. The first page is a PM form, which is on page 21. Page 22 and 23 illustrates the data that is on the form and where it came from. It's kind of an audit trail, and it's very detailed. And page 24 is a list of some common frequency code numbers for your use. On the second page on 20B, we have another series of pages for some what we call fixed PM activities, such as pages 25, 6, and 7 will address some PM work orders for the inspections of overhead cranes. Page 28 is a document from a company we worked with for instructions for the machine operator. And then finally, pages 29 to 31 are those data elements for a machine operator to lubricate a particular machine. Now, this is kind of moving right into TPM, but only relative to the lubrication program. So, again, we're going to look at these documents, and I'll take my time to try and address those data elements that may be foreign to your eyes or your ears as we go through the program. Now, moving to page 21. This is a PM work order, and you'll notice that we have on the top line equipment location and the equipment number. The second line, which is extremely important, is the equipment manual or reference number. Now, what this means is that the data that's on the PM form came from a specific OEM's manual, and the page number is addressed. There could be more than one page, and the specification number highlights the paragraph or paragraphs that the data come from. So you see, if there is any need to go back to the original source data, we have a complete audit trail on this particular PM form. The third page, or the third line, has to do with the schedule of that particular PM order. And if you move all the way over to bubble number 10 and 11, and I'll explain the bubble numbers in a second, bubble number 10 indicates that in that area we're going to identify by either the badge number or a group badge number, whomever is going to perform the PM. The sequence number is the sequence of that particular PM, and it indicates how many times that specific PM actually was accomplished in the past. The first time this company performs a PM, the sequence number is 1. The second time it performs it is 2. The reason for that sequence number, we may inadvertently over PM a particular asset or under PM the asset. So keeping track of the sequences at a later date as we gain experience could help us to, let's say, expand the time element between PMs or contract that time element. Now, going to the body of the PM form itself, we have operation number. Previously, we called it a sequence number on another form. We have the frequency code. We have the description. of the various activities. Now, in this case, this company includes the spare parts, the tools, the equipment, and the documentation that's required by the PM personnel right in the body. And then over on the right-hand column, we have PM comments to be made by the PM personnel. And down at the bottom, we indicate who originated the PM document and then who reviewed it and approved it. Now, a quick comment about those little lines on the body of this particular PM form. This was designed to accomplish two things. This company did not want to generate a job planning sheet, take the job planning sheet, and then develop a PM work order from the planning sheet and ultimately load it into CMMS. This document was designed to take the data that's in the OEM manuals, as I defined on that second line at the top of the form, and from there put that data directly into the PM form itself. So those lines will support a IBM Selectric typewriter, and it's double-spaced. When that form is completed, the form is read through a document reader, and then that data is automatically put into the PM CMMS program. I might also indicate while the document reader is reading the data on the form, those lines disappear. It has a special ink associated with the original source document of the form. Now, the bubble numbers are found on the next two pages, pages 22 and 23. And again, there's a lot of data here, and I'm not going to read it for you. I want you to read it. The form item number, starting at the top left, you'll notice those numbers 1 through 11 on the first page, and then if you turn to page 23, we have numbers 12 to 17. Those tie in with the bubble numbers on the form. The form item identification indicates what the data is relative to the bubble number on the form. And last, the description indicates the source document or wherever the data came from. This is a beautiful document to have, especially if you have machines where you're going to modularize or very large PM activities, or it can be used for the training of your craft personnel prior to moving them into the PM activity. So please, go back over these particular documents, look at them, you select what you want on the PM form, as I've indicated before, and then ultimately you'll have your own designed PM document. Now moving to page 24, which is the last page of these 4 pages, 21 to 24, are the frequency codes. These are common calendar frequency codes. I don't think they need any explanation. They're identified in basic terms, but I would like to address the last frequency code called FR. FR is a temporary frequency, and FR generally may come in from a machine operator to the maintenance organization, and it comes in different terms, like the machine seems to be making noise, it doesn't smell right, I think it vibrates, and other things that are a byproduct of the machine operator's observations and findings. Don't forget, they're not trained to make recommendations for operating improvement, not at this point in time. But when we move into TPM, we will address that issue. The FR code identifies what the machine operator has conveyed to the maintenance department. So every time a PM activity, irrespective of the frequency code, is printed out by this program, that FR code is identified. When that particular condition is eliminated or it disappears by itself, In some cases it will. There may be some temperature, atmospheric conditions that could cause some strange application. Then the FR code is eliminated. On the next series of forms, which I've indicated previously, there's 3 pages, 25, 6, and 7, and these are individual documents developed by a company for crane inspection. The first one on 25 is crane cable inspection. And again, the data is standard on here, and any, let's say, mechanic that has worked with cranes can review this data, and they can interpret what the form is trying to accomplish. If you turn to the next page, we have a monthly crane inspection, and this is for motors, brakes, and controls. So you see, for the same crane, the previous exhibit indicated cable inspection, and this document now is the inspection of the motors, the brakes, and controls. Each one of these, okay, is tied in with a specific location, such as the bridge, the trolley, and the hoist. So again, what we're doing is we're kind of using the modularization approach for that particular PM work order, so the PM operator knows specifically where to go to perform those monthly inspections. And then the last one is a monthly mechanical inspection. And again, it addresses the bridge, the trolley, and the hoist. This is laid out very succinctly for the PM personnel to minimize the lost time on the job trying to determine where is this activity to be performed. It's the roadmap to a successful PM program. So again, use these documents to help you to develop your individual PM work orders. Now, the next document on page 28 is an operator checklist. When we have operator checklist, my recommendation is to physically fix that checklist to the machine. Many people will put a document made from paper, and when they put it on the machine, they may put a piece of lucite over it, and then that lucite is permanently affixed to the machine, either through some type of a framing process or screwed right on the machine itself. And this is what the operator must do every time that machine is going to get started. You notice the first thing is safety. Check the safety devices. And then there are some gauges that have to be reviewed. In this case, it's the air pressure. We may look at a oil level on a gauge, or we may have the old-fashioned dipstick to go into an oil reservoir. Irrespective of how it's accomplished, that's a permanent step that must be done by the machine operator. They also lubricate, okay, per specifications. So there is going to be a separate PM spec tied right in with the lubrication media, such as the container that the lubrication is in, or let's say some type of a pressurized pump. It's a separate document from this checklist. And then we use brushes for cleaning, not air. That is a safety feature. Clean the work area at the end of each shift, and then remove the chips and burrs on the completed pieces. Now, this is merely one illustration of many, many operator checklists that I've seen. Now, the next 3 pages addresses the lubrication document that I talked about in the previous operator checklist. Now, this company here went through a little expense to actually develop these lubrication specifications as you see. This is an actual copy of a lubrication program that is out at the machine itself. Up on the top, the numbers that are bubble numbers from 1 to 13 address the bubble numbers that are on the left-hand side at the bottom portion of this particular lubrication chart. Those bubble numbers are similar to the development of modularized numbers. But this is not a modularized PM program, but we're using the same type of a technique. It tells the machine operator where that orifice is located for lubrication. It also indicates the frequency. And here, in this case, where you see 360, that says every day. So this is a daily lubrication. It indicates the type of lubricant and any other data to make certain that the operator is not using the wrong lubricant for a particular lubricating orifice. If you turn the page, this happens to be a continuation for that particular machine, and there are, again, all of the basic instructions relative to the bubble number, the frequency, where you see a frequency like on step 2290, that's every 3 months I have to perform that particular activity. Now, this is not left up to the machine operator itself. The supervisors have to come by on a daily basis and make sure that these inspection instructions or lubricating instructions are accomplished. And as we go from one day to the next, these lubrication documents can be replaced. Some can be permanently kept by the machine. That's strictly a management decision. Now, who's doing this? The machine operator. So the management of operations has to be brought in way before we institute a program like this to support the PM program and the consideration of the time allowed to perform these activities. If I remember correctly, the lubrication done for this particular application is giving the machine operator 10 minutes at the beginning of the shift to do the lubrication process. So again, those 10 minutes are removed from the production planning, capacity planning program. And that's really what is a key consideration when we start to integrate the machine operators into the PM program. The last document is a operator oiling instruction, and you'll notice in this case this is what we call a very mobile type of a document. The operator has to literally check off based upon the frequency relative to those particular lubrication instructions, and at a weekly basis this document is picked up and reviewed by not only the supervisor of that department, but it is then therefore forwarded to the maintenance department for review, subsequent recording into the PM program, and then filed. You'll also notice one important feature about this document. Machine cleaning is a 3-shift operation. So each shift has its own little area where it records what they have actually done relative to their responsibility for this PM program. Now that concludes some of the documents that we've talked about, and what I would like to do now is talk about the loading and scheduling of the PM orders into a loading and scheduling system. And the way this actually is developed is I want you to merely quickly turn to page 34 for 1 minute. And you'll notice that we have an elongated diagram that represents either a first, a second, or third shift. So what I'm going to do is I want you to come back to 32A and talk about the development of the data that is used in page 34, because 34 is really a physical diagram to show you how those hours are used in a loading plus a scheduling system. Step number 1 on the top of page 32A indicates that we're going to have a weekly capacity plan of 240 hours. So that's what we're going to load to. If we look at a daily plan, we're going to have 48 hours of capacity. The capacity plan, in this case, requires a 3-shift capacity plan. So step number 3 indicates the capacity available, that is by craft person, on the first, the second, and the third shift. Now, as I indicated a minute ago, page 34 illustrates how that capacity plan is identified by the first, second, and third shift. In the loading process, it is advisable to load to a weekly capacity plan. Okay? Then you can remove that weekly plan into daily, and then from daily into shift. Continuing now on page 32, when the planner schedulers the PM work orders, we want to schedule, as I've indicated, and I'm putting it in writing here, 1 to 2 weeks into the future. All this time, the planner scheduler should schedule to the smallest time element possible. In this example, the planner scheduler would schedule within a shift within a day. So you could see we could take the weekly plan, break it down to a day, and ultimately to a shift. Page 33 of this section addresses the steps the PM work order planner and scheduler takes going from the loading process to the schedule process of PM orders. So let's move over to page 33 and take a look at those particular steps. The PM work orders are converted into craft capacity requirements. That merely illustrates that if I have an electrical PM activity and it requires 4 hours, then that means that 4 hours of electrician's capacity is going to be removed from the available capacity plan. When I do that, I'm going to assign those 4 hours, that PM work order, to a specific individual. And here is where I start to utilize the badge number of that particular craft person, and to kind of make it more personalized, yes, I can use that person's name and actually put the badge number and the name right on the PM work order. And step number 2, the PM work order craft capacity requirements are loaded into the craft capacity plan by planned required date. Now, here is where we start to get into the detail of scheduling. What date is it going to be required, and is it going to be required a shift within a date? The step 3 indicates the planner scheduler tries to balance the PM work order load to the PM capacity plan. The planner scheduler has several options to meet the PM work order due dates. One option is to increase craft capacity. In other words, put a second person in that capacity plan. B, if I can't add additional capacity, I'm going to have to reschedule the PM work order date, or C, reschedule the PM work order by shift. So the key is there available capacity where my demand of the PM orders exceeds the capacity plan? The way you don't trap yourself into that condition is when you load to what the capacity plan illustrates. And remember, we're loading out into future time periods. If the demand, which is the summary of work orders by craft, is starting to equal or go over the capacity plan, then I could do the rescheduling, if you will, in the planning process. Once we've executed and released the schedule, we may have to increase the capacity required based upon the availability of, let's say, the asset from operations. The fourth step indicates that the planner schedules the PM work order by date and by shift. So now we're in the process of actually putting down the date code and the shift code on the PM order. This scheduling step is called finite scheduling. There are two terms that may be foreign to your ears. When we load, we call that infinite loading. Infinite means I'm not going to pay too much attention to the demand against the capacity plan. I'm going to try and balance that out as I start to get closer to that planning process by due date. Finite says I'm going to balance the capacity to the requirements. And those are two common terms that you'll find that the planner schedulers over in operations use day in and day out. Now on page 34 is the development of the craft capacity plan by week, then also by day and shift. And as you can see, we have, starting on the left top, we have our capacity analysis. We have a 5-day week with 8 mechanics. These mechanics are working 3 on the first shift, 3 on the second shift, and 2 on the third shift. Now, moving down along the left-hand side, we're going to develop the capacity requirements for those 3 shifts. So we go through the calculation. We're basically showing you how to do this. 5 days times 6 hours per shift. What we've done is we've factored down the netting of the capacity requirements. Remember, going from gross to net. So in this case, we're only going to schedule 6 hours against 8 payroll hours, times the 8 mechanics is 240 hours. Moving now down into the more detail, we're going to have the total shift capacity. The first shift has 6 hours times 3 mechanics is 18 hours. Likewise, similar to the second shift. And then the third shift only has 2 mechanics, so we have a total of 12 hours. So the total daily capacity is 48 hours. The total weekly capacity is 240 hours. And the individual daily shift capacity requirements are 18 respectively for the first and second shift and 12 for the third shift. This is this migration I talked about, going from a weekly plan to a daily plan down to a shift plan. Now, the capacity is demonstrated, if you will, on a weekly plan for the first, the second, and third shift. Now the next task would be to take my work orders and start to actually load them to these capacities. That's called infinite loading. Once I've done my loading, now I'm going to do the scheduling, which means I'm going to develop the date and shift codes for those specific PM activities. And now I'm ready to, let's say, start releasing on a daily basis, 1 day in advance, or maybe on a shift basis, 1 shift in advance of the individual PM work orders. Now, what we have just developed for you in section number 5 are the details of planning and scheduling. I believe if I've done my job properly, you should have all of the tools in the notebook at your disposal to develop your PM program intelligently. Remember 2 things: plan first and schedule second. Now this concludes section number 5, and we will start to move into section number 6, which is really the reporting element based upon the craft person's observations, findings, and recommendations for operating improvement. In section 6, as I indicated a moment ago, we're going to talk about the maintenance work order reporting. Now, before we get into the detail of this section, let me make a comment relative to craft personnel. Maybe today in your maintenance environment, you may not be doing any reporting. Maybe you have a reporting system that will clock in and out on an unplanned order. There are many different applications of reporting. But here we're going to talk about the disciplines of reporting in the PM program. And when I say disciplines, I'm not talking about the disciplines that tie somebody's hand, keep the hand out of the cookie jar. What I'm talking about is how much reporting do we want to have from our PM craft personnel? Well, the 4 data elements we talked about originally was the time on the job, observations, findings, and recommendations for operating improvement, and number 5, are there any changes that should be made on the PM order? Those are the 5 critical data elements. Now, when we talk about time on the job, remember there are 4 major time elements in the PM program: preparation time, travel to the job site, the work time, which can consist of many, many steps, and then travel from the job site. You're going to see that you have some options relative to where within that work order you want the PM person to clock in and clock out on the job site. So those are the things now that we're going to be discussing in this particular section. So you're going to develop the reporting system. We're going to try and prepare you with the data in section number 6, how to develop the reporting system. So let's start off with item 1 on page 1 and indicate the only data that I need reported is the work order number. Now, I need the badge number of the employee. I don't need the asset number. I don't need the description and where it's located and so forth. The work order has all of that particular data. So let's keep the reporting system for our PM personnel to an absolute minimum. Secondly, I need time on a job. Now, I just went through that, so I'm not going to repeat it again. Which one of those time elements do you want to pick and choose? Well, we have a document in this section to help you make up that particular, or make that decision for you. I've talked about the clock number. We have spare parts used. Now, if I had 3 spare parts issued on an order and I used all the spare parts, I don't have to report the spare parts by part number used. But if, let's say, 1 was not used, then that means maybe we have the wrong part number, or we added a part to the PM order and it wasn't required. That's the type of feedback we want. Special tooling, was it the proper tool? Likewise, equipment. And also, don't forget the documentation. Now, the most important thing that I want from the PM individual is his or her observations and findings. And you remember at the beginning of this seminar, I said you're going to hear me talk about observations and findings and recommendations for operating improvement until you're probably sick of hearing about it. Don't get sick of hearing about it. That's the key to a successful PM program, over and above keeping your assets at their highest point of operation. Item number 8 is the work order status. Is it complete or is it partially completed? Sometimes in a multi-shift operation, I may start a work order, but I don't have the total time to finish it. And maybe rather than have people stay from one shift to another, we'll get the next shift to actually get in and finish that particular work order. Item number 9 addresses things that are to be returned to the storeroom. The unused parts, as I indicated before in step number 4 above, the special tools, the equipment, and documentation. Now let me talk about return documentation. Sometimes these documents are going to come back in really a sorry mess. They could have grease and oil and be crinkled and so forth. My advice is to get a shredder in the storeroom, check off the documentation that it was returned, and put it through a shredder. That will eliminate the possibility of having proprietary data find its way out into the street. Now, item number 10, what else do you want from the craft person? Well, I think one thing that, Frank, you didn't indicate here is what about operating conditions to recommend the improvement of the piece of equipment? We have observations and findings in step 7, but I didn't put down here recommendations for operating improvement. And I'm not trying to, test you, but those are some of the additional things that I want you to consider in 10, 11, and 12. Now, moving over to page number 2, we have the data elements relative to what we talked about in reporting, and here we're going to actually execute that. Do I want actual prep time? Do I want actual travel time? 1 and 2 is a management decision. Do I want actual time on a job? My answer is yes. What about the spare parts usage? Yes. Observations and findings, you doggone right. And what about 6? Yes. Travel time from the job, that all depends on how much travel time is associated with the order. Now, other considerations, as we indicated in the data sheet on page number 1, is the unused spare parts, the tooling and equipment returned to the storeroom. Return the work order to scheduling with all of its notes on it. In some cases, there may have to be some dialogue between the planner scheduler and the PM person. And again, in other cases, the maintenance supervisor may want to get involved in that dialogue. If there are any structural equipment that was issued out, we want to have that returned to the file if it is in good condition, otherwise shred it. Now, on page number 3, we're discussing the closeout steps. Remember, we have put the hours of requirement into the schedule. They're going to remain there until the work has actually been done. Now we're going to remove that work order and its associated time from the schedule. So that is accomplished in step 1. If the PM work order was not completed as indicated in step 2, then we're going to have to reschedule the order. You may find that a person is going to go to the job site and for some strange reason the equipment is not available. Let's not waste our time. Get that order back into the planning and scheduling environment and let's reschedule it. Now the third step is to calculate efficiency. Efficiency is the analysis of the actual time on the job to the estimated time. And again, we could do this by the prep time, the travel time, and actual time on the job. Step 4 is the calculation of utilization. Utilization is the total time on the job. And 5th is the analysis of actual spare parts usage. That's going to be done by the inventory system. The sixth element is the schedule, revise the schedule as required. That's going to be done by the planner scheduler. Now, other considerations relative to the PM closeout steps is revise the work order data as required. What I'm addressing here is this dialogue that you, the planner scheduler, and the craft PM person is going to discuss relative to the time estimates on a job, the sequences, and any other application, like we didn't have the right spare part, we had too many spare parts, we didn't have enough, we didn't have the proper tool, we didn't have proper equipment, or we lacked documentation. Those are the key elements that we want to have an open dialogue. That's going to help us to finitely tune the accuracy of the data that's on all of our PM work orders. And the next step, if you're utilizing craft efficiency, and I talked about this earlier, then here you could update the craft efficiency in the record, okay? And moving on now to page number 4, we're providing you with the efficiency formula, and here again is where the work order time is divided by the actual time, multiplied by 100 gives us the percentage of efficiency, and as the data illustrates under utilization, it's a summary of the time spent on a job. Now, I could summarize utilization as the paragraph indicates. I could do it by shift if I wanted, which is daily. I could do it by week. I could summarize by month, quarter, and so forth. That, again, is a management decision. And what you're basically doing here is you're comparing time on a job to the payroll time or to the total net available capacity. In other words, how effectively am I utilizing my net available capacity? At some point in time, we want that figure, as a recommendation, we want that figure to be up to 80 to 85%, if not more. Okay? Now, the following page, page number 5, is an illustration of developing the efficiency for a particular example. The time elements, as on the work order, are indicated at the top portion of page 5. The prep time is 15 minutes, travel to and from is 20, and the actual work is 3. When I receive the order back from the craft person performing that PM activity, the planner scheduler will feed that data into the system that will generate the efficiencies and also the utilization analysis, which is on page 6. So the efficiency calculation is indicated by the prep, the travel, and actual time. In this case, you can see that that employee is working in an inefficient environment. But don't jump on the employee. One of the things we have to consider is the time estimates on the job appropriate? And here again is that dialogue. So we want to find out, why did it take more time than what we had actually estimated? Now, turning to the next page is the analysis of utilization. If you remember, we had a total time of 3 hours and 30 minutes allocated for the job, but it actually took us 4 hours and 15 minutes. So we spent more time on a job. So therefore, it's important to open up this dialogue between PM personnel and the planning and scheduling activity. I may make a comment. Let's not have thin skins when we open up the dialogue. That should be an integral part of the training of the craft personnel when they move over into the PM environment. It's part of the training of the planner scheduler. Don't forget, we're estimating. How accurate is the estimate? this is one way that we can fine-tune the estimate. Now, on page number 7, we have what is called the craft utilization coding system. This helps us to develop not only the utilization of craft personnel, but the distribution of that utilization. In other words, I pay you 8 hours a day, maybe on a 5-day week, 40 hours a week. Where did that 40 hours a week, where did that 8 hours a day go? This particular exhibit will help you to develop what we call a labor distribution reporting system. Things like startup time and rest periods and maybe lunch periods and cleanup time do not have to be reported. Those are fixed within the system. So we would go from our gross capacity of 8 hours down to, let's say, 7.5 hours or 7 hours available capacity. That's what we want to address here. Those 7 hours of available capacity, how well did we use them? What we're trying to do is provide you with the tool so that you can move that 30 to 33% of craft utilization up to 80, 85%, if not more. The analysis of labor distribution helps the supervisor as well as it does the planner scheduler to determine that distribution of labor. Now, I told you we were going to supply you with a document to help you make the decision on the type of reporting that you require. And that is identified on page number 8. We have the time elements identified. Remember, the P is prep time, travel to the job site, the work time, and the travel from the job site. In this case, I'm not going to address C because that could be fixed 5 or 10 minutes. Now, the little matrix down at the lower left-hand column or bottom left-hand side of this particular document indicates the options that you have relative to clocking in and out on jobs or reporting in and out on the jobs, in addition to the individual data elements, prep, travel, and work. So I can't make a decision for you. My advice is if you want total time on a job, then you will report 1 and 5. If you want to measure, which I recommend strongly you do, the actual time on a job for work, then you're going to clock in and out on 3 and 4. Most small companies will only consider 3 and 4. Larger companies will consider 1 and 5 and 3 and 4. And I have worked with some companies that are spread out over 20, 30 acres, and the craft personnel, when performing PM activities, actually use a pickup truck going from one facility to another, one process to another, especially in the petrochemical industry. They want, that is the management wants, clocking done on all of the 4 time elements. And why not? Part of the resource of capacity planning is to know where it's being expended. Now, what we have done is we have just concluded, if you will, the reporting section, section number 8, and we now want to move into what we call the financial analysis of the PM program, and that is in section number 7. And here we're going to look at different methods in which we can extract all of the costs from PM, not only the costs but the benefits from PM. And again, you're going to see that this is something that you have the opportunity to tailor to you, the supervisor, and to other key management personnel in your organization. Now in section number 7, we're going to review the various cost elements of the PM program. And then in this section, the last few pages, we're going to take a look at a couple exhibits in terms of how to refine the PM program and even apply cost reduction opportunities to the PM program. So first, let's take a look at page number 1 and look at the various cost elements that are an integral part of the PM system. The most common cost element, number 1, would be the labor. Second would be the spare parts. Now, don't forget, again, spare parts could include lubrication, cleaning media, or any other material that is required in the PM program. The third cost element, which not too many companies use, but it is my recommendation that it be included in a PM costing program, is the maintenance department overhead. And on page number 3 of this section, I have listed for you the various cost elements that would go into an overhead account. The overhead account is distributed as a percentage of each craft labor hour. Your financial department can help you set up the mechanics on how that distribution is accomplished. They're very familiar with that, especially in an operating environment like manufacturing, because all of your plant overhead is distributed on a similar type basis. Overhead as a percentage of craft hour. You may have contract labor support the PM program. You may have to rent special tools to get started, and I would recommend you rent it before you purchase it. Likewise, equipment, and in many cases where you're going to, let's say, augment PM through the predictive maintenance operation, you're going to undoubtedly need some diagnostic equipment. Rent it first before you purchase it, because in many cases that diagnostic equipment is rather expensive. We may have a machine operator's time associated with a PM. And in some cases, we may have the support of facilities engineering. So their time where they expended on a PM activity should likewise be costed against that PM work order. Now again, no list is never complete, so therefore, what additional cost do you, as let's say a maintenance supervisor and your top management personnel, want to see relative to the PM work order? Now moving on to page number 2, we can talk about the individual PM work orders as completed and how the PM work order should reflect the individual item costs as indicated in page number 1. We want to take that work order cost and apply it on a daily basis if it occurs daily, and PM is a daily activity, but not necessarily for all of the PMs daily for a specific machine. But as we develop the PM cost, that cost should be recorded by equipment and asset number. And as you could see in the 3rd paragraph, we can summarize the cost by week, we can summarize it by month, quarter, any time period that is required by you in maintenance or by other management personnel. But the key is to ultimately have an annual summarization of the PM cost by machine. And as you start to move more and more into PMing additional assets, and we continue the PM program on the original assets that you've implemented, PM activities, You're going to be measuring, as I indicated earlier, the difference between running time and downtime. And here again, you want to record that by asset and machine number. As the PM takes hold, the running time should continue to go up and the downtime should continue to go down. That is a quick means of measuring the effectiveness and likewise the return on investment for the PM program. Now on page 3, as I've indicated before, are some of the cost elements that you may consider in your overhead analysis. Not all of these may be required in your particular overhead analysis, such as you may not have a plant or facilities engineering function, but any portion of their time that is used to develop and support the PM program should be charged to the PM program as overhead. Likewise, all of maintenance supervision, the individual or individuals that are responsible for inventory management or inventory control, the purchasing function, those that are in planning and scheduling, and if we had to, as an example, put someone into the receiving inspection activity in the storeroom, that's an integral part of the quality control cost. The individuals in the stores or warehouse, the material handling group that would actually deliver material to the job site, and in some cases those could be an integral part of stores and warehousing, and then any clerical or secretarial support in the maintenance operation. And if, as an example, you're utilizing a total CMMS program or partial functions within CMMS, and at least those that are supporting PM, that cost should be added to the overhead function. And then any type of supply costs. And again, others that may be required. Those are annualized and they are then amortized over the PM hours as a percentage figure. And again, let the financial department help you with the distribution of that overhead percentages. Now, as I indicated a moment ago, we want to measure the running time versus the downtime. So page number 4 is addressing that. And again, EMA is equipment machine asset number. It all depends on how many of those machine asset numbers you are using. What you want to do is to determine, like I said, the running time against the downtime. Please, if you do not have production for a machine, like maybe you don't have customer orders for a machine and it is down, that's not the downtime we're talking about. We're talking about the downtime as a basis of a machine failure. And here again, we have to have honest reporting from operations. I have been involved, as I've indicated before, with hundreds of companies, and especially companies in manufacturing. And a lot of machine problems are not machine problems that were generated because of, let's say, faulty spare parts. But much of the downtime was caused by operations itself. Poor setup of tooling, the improper use of the equipment, the development and the generation, if you will, of scrap and rework, very low production as opposed to the actual time and the quantity produced versus that which is on the manufacturing routing. I've seen in many cases those data elements be charged to the maintenance as machine problems. You have to be very honest here, and here is where I sincerely recommend that finance, operations management, and maintenance management review the operations reporting system. We want the true machine downtime as a byproduct, as I said a moment ago, of let's say, machine failure as opposed to operator-induced failure. Now, on page number 5, we have developed for you a list of major returns of the PM program. Some of these can be identified in time. They can likewise be identified in dollars. And, you know, previously we talked about the cost of the PM program. Here we're talking about the advantage of the PM program. The concept to generate PM costs versus the returns is very simple. You don't have to be a CPA to determine the byproduct of the PM program. Let me give you just a rough illustration. Let's say that I have put $200,000 into the PM program. I have generated an additional $150,000 of, let's say, cost of goods sold. Not sales dollars, but cost of goods sold. That's the return on that particular $200,000. An additional $150,000 of products that now I can sell. So let's take a look at some of the items here. Some are self-explanatory, and maybe one or two requires just a little comment on my part. Less production downtime, that's obvious through reporting. Less overtime pay. Now that is for both the operations as well as the maintenance department. Fewer large-scale repairs. That means a machine went down and there was some machine breakage. A lower repair cost overall. If I'm in a firefighting, a reactive environment, I'm going to be spending a lot of time and money keeping equipment in top-notch operating condition. The PM program, I know what those costs are, and they, in many cases, are going to be less than those costs that are associated with a reactive or even a proactive maintenance operation. Fewer product rejects, and that again pertains to the accuracy and the honesty of operational reporting. Decline of maintenance costs, absolutely. We can increase the craft utilization, and if I go from 40 to 80%, that means I've doubled the productivity with the same payroll. I have reduced inventory investment by 70 to 80%. The carrying cost on that could be thousands of dollars. So the sum of those two is going to help me reduce our maintenance cost in total. Better spare parts inventory control through the inventory management system, and especially where we move toward vendor stocking programs. Better industrial relations. That is, we're working in a, let's say, a non-reactive environment. We're producing more parts. The company is making more sales dollars with the same, let's say, complement of direct and indirect labor and operations. And conceivably, there's going to be some key major financial returns by that. And people are working in the shop in a safer environment. It's kind of hard to put, let's say, a dollar and cent on greater safety or better industrial relations. And I'm taking 8 and 9 and talking about both of those simultaneously. But you're going to see that there could be a tremendous attitude change on the part of not only the labor in the shop, but also the labor in the maintenance department. Lower unit cost is a byproduct of reducing your overall overhead cost of the products that you manufacture. And one of the key contributors is going to be the reduction of the maintenance cost. But the other contributor to that is the ability to increase asset running time, which means I'm going to be producing more parts, more products with the same equipment and the labor that I addressed previously. Now, item number 11 requires documentation as all the others do, and that is the identification of high maintenance cost terms due to, and this is operational reporting, misapplication. I'm using the equipment for a function where the equipment wasn't designed properly. Operator abuse, or having obsolete equipment. We've talked about the obsolescence program and the need for a spare parts where used list to eliminate that. But 11A and B fall squarely on the shoulders of operating supervision. And last but not least, what we want to do is shift from what I call an inefficient, breakdown firefighting environment to a less costly, scheduled maintenance environment. Now, the next two exhibits actually talk about cost reduction. Now, my recommendation is try not to move into this cost reduction program until your PM program has just been about, completely designed and solidified. These documents are for your use, let's say in some future time period, maybe 1 or slightly more than 1 year from now. Some of the things that you may want to consider is look at those PM activities that have high labor costs. Look at those non-PM activities that would have high travel costs. And here what you want to do is select those type and then observe what is happening currently. And thirdly, analyze the different sequences or operations to determine, can we do this more expeditiously? Is it possible to eliminate a particular step? Or can we do something that is a little different than the way we are performing a particular step? Let me give you just one illustration. One company had many operating equipment on a continuous basis, like in the paper industry. One of the time elements on the PM program was to dismantle or disassemble an end plate to review the condition of bearings. In most cases, there were 12 to 16 bolts with lock washers holding that end plate on. Currently, the operation was to take a socket wrench and take those 12 to 16 bolts off. And there was no consideration of cost reduction or operating improvement at the point that the PM program was designed, because that's the way we did it, for 100 years. In the cost reduction analysis, one of the PM operators said, hey, why don't we run an airline over to that machine? We've got airlines all over the facility, and let's take a pneumatic tool, plug it into the airline, and reduce this dismantling cost by 75%. One little operation like that saved that company hundreds of dollars in not only the time but the cost, because they had many pieces of equipment that was being dismantled the same way. So what you learn in one area can be actually executed in others. So that's what we're talking about. Challenge and then explore. And once you've gone through that explanation and exploratory type of an activity, then implement the best way. Change it on the PM. Purchase a pneumatic tool if you need it. Most shops have them for that illustration I've just gone through. And then continually review and review until you feel that we've done enough analysis, and I think we're at utopia. You're never there, okay? But that is the PM cost reduction steps. Now, to reduce the costs, there are other applications like the methods of inspection and servicing to do a better and faster job. The previous exhibit was the outline. The planning of methods of inspections and their routes. If I have to go from one plant, let's say location, to another plant location that is at the other end of the facility in a sequential scheduling environment, I'm going to be wasting a lot of time in this travel time area, and that's what I talked about. Look at the work time and also look at the travel time. We may want to resequence PM activities in a more closer proximity when we think about sequential scheduling. Other cost reduction opportunities is to do a better job of planning overhauls, planning both major and minor overhauls. Other things you want to do is where you have repetitive overhauls, like I'm going to do a minor every 6 months. And maybe as you do the overhaul and we, let's say, replace parts, it may be a good idea to send those parts out for analysis, wear analysis, and other types of analysis that may provide you with some input, and the end result would be to not make that minor overhaul every 6 months, but change it to 8 to 9 months. Those are the byproducts of reviewing repetitive overhauls with some inspection of the products that you're changing. Provision of better tools and test instruments. The pneumatic versus the socket wrench is just one illustration. Redesign of the equipment to speed up the manufacturing process. You're going to find that when you move to TPM, total productive maintenance, your machine operators are going to make recommendations if they're properly trained, and that is a requirement that we want from them for operating improvement of equipment. The other two applications is to install predictive maintenance and install total productive maintenance. And coincidentally, the next section, number 8, is addressing the introduction to predictive maintenance, and then section 9 is the introduction to TPM, so that when you're instituting your PM program, as I said earlier and many times previously in this seminar, the things you want to consider to enhance PM is instituting predictive maintenance next, and then thirdly, institute TPM. So now what we're going to do is move over to section number 8 and review a few exhibits relative to the makeup of the predictive maintenance program. Now, starting on page 1A, we want to go into the definition of predictive maintenance. Predictive maintenance has been around for many, many years. One of the first steps of predictive maintenance was generated when companies, and maybe like yourself, were sending, let's say, lubrication media out to a service organization for analysis of machine wear and any other type of application. And I think the second predictive maintenance innovation, if you will, was done by a manufacturer of luminaries, where they estimated that if you were to change your luminaries after so many 100 hours of continuous operation, you're going to be able to save not only the maintenance time by replacing one, let's say, bulb at a time, as opposed to taking a mass change. Those are predictive maintenance applications, the original predictive maintenance functions. Today, as we get into more, high-tech manufacturing equipment and processes, using such things as electronic devices. We're looking at robotics. We're in the CAD/CAM environment. We move towards cellular manufacturing, and some of the larger companies have moved toward what we call focus factory, where we have smaller factories within a very large facility. We have changed our predictive maintenance approach. We haven't eliminated the lubrication analysis and so forth, but we want to get the highest degree of productivity out of our assets. So in those cases, we have added such things as diagnostic equipment to the predictive maintenance program. In order to properly use diagnostic equipment, we have to have the support of either the asset OEM or from either our facilities engineering, if we have it, or from a machine design engineer to establish what we call the operating profile of a particular asset. Now, operating profiles come in different dimensions. There are vibration profiles, there's feed and speed profiles, there's temperature profiles, there's pressure profiles, and others depending upon the specific machine that we're going to analyze. And page number 1A addresses the establishment of operational profiles. When we move over into 1B, we want to be in a position to monitor that profile that we've established with the use of diagnostic equipment. And generally, that can be done by the machine operator. However, there have been advancements made in computerization where some of this diagnostic analysis is being fed directly into a PC-based predictive maintenance program. And that data is likewise being fed into the PM program. So when we're reaching either a high or low parameter on that operating profile, the next process is to issue the PM work order to eliminate a potential machine failure. And that is the element of the paragraph on page 1B. And the last sentence describes exactly what I'm talking about. The objective of predictive maintenance is to increase the utilization of our equipment. Now, moving toward page 2, predictive maintenance pinpoints the operating deviations relative to that operating profile. The easiest way that I could explain what's happening here is for those of you that have established, work in process inspection procedures through your statistical process control environment, SPC. Here the machine operator through its bar XYZ charting is actually looking at the physical dimensions of the item you're making. The physical dimensions are compared to a blueprint or let's say some operating tolerances, and that is identical in nature what predictive maintenance is accomplishing when it is monitoring a machine relative to its operating profile. Some of the predictive maintenance objectives are outlined in page number 3. And you'll notice that many of these are identical to the objectives of the PM program. Reduce equipment failures, starting with 1. Reduce emergency orders is 2. 3 is to identify correctable failures. Well, PM intervals won't do that. So this is a key input and a key objective of predictive maintenance. Identify correctable failures. How? Through the monitoring of those various operating profiles that we just discussed. Predict failure points. Here you have to have the input of machine design, either internally or externally through your OEM, or have some machine design engineer support the development of those failure points. And again, they could be vibration, pressure, temperature, feed speeds, or any other application that must be monitored. You're going to reduce maintenance costs. Predictive maintenance may give you an opportunity to replace some of the PM activities that are not machine generated by machine hours, but are calendar generated. So immediately, if we could start to reduce some of the PM activities, we're going to start saving not only the labor cost, but we're also going to save the spare parts cost. We want to reduce the production downtime. Well, the opposite of that is having increased utilization of assets, and that's the name of the game of predictive maintenance. We want to improve product quality. If a machine is running in its norm, which means it's operating way within the operating profiles, then that machine could or should be producing excellent quality products at the productive rate that the machine was designed for. Reduce equipment damage, and that again is a byproduct of step number 4 above, and extend the equipment life. Through PM and through predictive maintenance, we should be able to extend the life of the equipment by monitoring the profiles and changing spare parts, doing a better job of lubrication, more frequently, if you will, or on some other schedule basis to keep that machine in operation. On page number 4, we're talking about some of the steps necessary to implement predictive maintenance activities. First all, item number 1 is the first step is defect definition. What do I want to monitor? Well, one is time, another one is frequencies, and then from there we want to measure the progress of the predictive maintenance program. Some of the predictive maintenance requirements are through analyzation. We may be looking at, as item 2 indicates, some equipment statistical analysis. We look at vibration analysis, and we can look at operating measures, and these are some of the operating profiles like strain gauge analysis, dielectric relative to, let's say, impedance characteristics, the current flow, and that could be the flow of current as well as other applications like water, pneumatics, and any other type of flow environment, pressure and volume, and there's our speeds, and then here's our temperature relative to heat. So 2 is trying to provide the guidelines relative to things we want to consider for a piece of equipment. Remember, all of these items that are identified in step 2 may not be required for each and every machine, but they should be addressed. 3 is the correction control. When we see something that is moving toward those ranges in the operating profile, the planner scheduler has ample opportunity, like I said earlier, to establish corrective action through the PM program. The date says when do you want to make that spare part change or any other PM activity to eliminate machine downtime. Monitor the correction effectiveness. Is it going to give us the additional running hours that we're talking about? Can we eliminate some of the PM steps that are currently in the PM program? The way you do that is you have to maintain a recording system to show how the predictive maintenance program, which is enhancing PM, how effective if it is going. Now, some companies will ask the question, well, where do I get started? And just like we developed some starting points for you and ways to get started in PM, some of the things that you may want to consider is what we call a A-B-C analysis, not like that in inventory control, but that relative to operating activities. The type A is the most critical element, and it could shut down an entire plant. What could shut down a plant? A failure of a power generating facility or a substation. The main boiler or the boiler feed pumps could go out. Or let's say you have a single compressor unit where the air is being distributed throughout the facility. If any one of these three happens to go down, it could shut down an entire facility. So here again would be a starting point for what we would consider major problems relative to operations. The type B would probably shut down a department, and those are identified as assembly line conveyors, power distribution switchgear coming off of a power distribution system from, let's say, your own generating facility or from your main power source. And then item 3 would be exhaust systems, where exhaust systems are a necessary function to maintain the integrity of the operating environment. Moving on to page 5B, we could talk about the lesser type of a problem that would, let's say, shut down a line, and that's what we refer to as type C. We could have a paint line failure, a bridge crane overhead could fail, and a single non-spared production line could likewise fail. Now, if we had failures here, we probably within some time could get another process in operation. But we don't want to have those machine or paint line failures and so forth. But I'd rather have a paint line failure than shut down a complete facility. So what we're doing is we're kind of categorizing the highest to the lowest predictive maintenance implementation program. The last one, which is our type D, would shut down an operation. That would mean a single source asset, like a machine. We could have a drive failure, and here that could be caused by vibration, likewise by speed, or a motor failure, or a bearing failure. Now, these failures that I've just outlined in A, B, C, and D types are not the only ones, okay, that could cause those types of failures. These are just illustrations for your perusal, and you should identify in your own area and categorize the critical to the least critical, and that will help you, just like in PM, to implement the predictive maintenance program. Now, in page number 6, we're addressing what we call the equipment baseline data, which I have been referring to as the operating profile. And it really indicates that to develop this through either the manufacturer's equipment operating specs or by the measurement, if you will, of operating performance. To get it started, you need some machine design input. Don't try and do this yourself. Now, I'd like to just make a comment relative to the suppliers of predictive maintenance equipment. Many of these suppliers have well-educated and well-experienced personnel on their staff to help you install and support a predictive maintenance program. After all, they make their income from either selling or leasing or renting diagnostic equipment. If they didn't know how to support that equipment in use, they wouldn't be in business long. So another opportunity is to work with more than one supplier of diagnostic equipment, and they can help you to install the program at no charge on the assumption that you are going to lease or ultimately purchase the equipment from them. That's some good free advice. On page number 7, we're talking about the establishment of the operating profile. Those are the limits relative to the piece of equipment. The operating norm is called the baseline. And then we have the parameters set up, and those parameters are established through different applications such as heat, speed, feed, vibration, and other applications to monitor a piece of equipment. The equipment tolerance limits, as identified on page 8, are those that the diagnostic equipment is going to measure, okay? And again, that could be done by the machine operator through a charting process. It can be done automatically by the diagnostic equipment itself through its recording process. And like I said previously, we can actually tie the diagnostic readings right in with a PC-based maintenance system to support the predictive maintenance application, and then that would be fed directly into the planner scheduler for action. Now, the last exhibit in this section, page number 9, is a list of some of the more commonly used diagnostic equipment. And again, I'm not going to make, let's say statisticians or predictive maintenance, experts out of you by reviewing this list. It is a requirement of the type of diagnostic reading that you want to institute in your predictive maintenance program. What you are trying to monitor would probably be done by one of these measuring and monitoring devices. And again, no list is ever complete. Item number 12 says there's a myriad of different applications that can support predictive maintenance. Now, what I've tried to do with this section, section number 8, is to at least address predictive maintenance as an overview. Remember, the first page says it's an introduction. This is not a program on predictive maintenance by itself. And at some point in time, we will have a predictive maintenance seminar. And we will also support that with a TPM seminar. But at the beginning of PM, consider the use of predictive maintenance applications to enhance the PM program. Now what I want to do is to move into the last section in the notebook, section number 8, which is really the introduction into TPM, the Total Productive Maintenance Program. Now, as the first page in section 9 illustrates, page 1A, this is the introduction to the Productive Maintenance Program, which is really called through its acronym TPM. As the first paragraph illustrates, TPM is an application where machine operators and all other operators of other assets will participate in the maintenance management program through the PM activity. Previously in this seminar, I've indicated that people like truck drivers, forklift truck operators don't have the title machine operator. We embrace all the individuals that operate any asset as a machine operator. And what we're trying to do is to minimize the machine problems, the tooling problems, and material problems, and other related quality problems, and poor customer service by the support of the operating people in operations. Now, moving on to page 1B, looking at the first paragraph, anything that could lead to any type of a negative condition as outlined in the previous page should be considered to be introduced into the TPM program. TPM, like we've covered in section number 8 under predictive maintenance, is a continuous process for manufacturing improvement. We're not doing this like on a fixed calendar frequency date. Here we're doing this all the time while the machine is in operation. Now, when the machine operators assist maintenance personnel in the PM program to, let's say, change spare parts, then that type of TPM is the support of the actual maintenance PM program. So we basically are looking at two things: machine operator participation through the analysis of the equipment while it's running, and also their support and assistance in doing actual maintenance work. And as the last paragraph on page 1B signifies, TPM and PDM and PM applications working together should provide the highest degree of performance and longevity for our equipment. Now, there are 5 basic elements of TPM. These are like the capstone of the TPM program. The first one is equipment process training for operators, and that is cross-training an operator to understand maintenance needs and have maintenance personnel understand operator needs. The cross-training is accomplished by 1B, and that is the training and the education. So you could see this is another activity like PM, like predictive maintenance, where we have to do some planning up front, identify the elements of planning, and then execute it. Remember, planning precedes scheduling. In this case, planning precedes the execution of the TPM program. Now, we want to have machine operators feel that they're autonomous individuals. Number one, that autonomy means that they own the equipment. One of the interesting features of some companies when they have a TPM program is at the initial stage of interviewing new personnel, they actually indicate and go through a training program. And that training program may be 1 to 2 weeks in duration before that new employee actually gets out into the shop and becomes an operator. They say, we will provide you with the machine, it belongs to you. We will give you the tooling to produce a product. We will give you the, let's say, materials that go into the production of that particular product. What we want from you is to make certain that you keep the equipment and the tooling in the highest operating condition that is humanly possible. And that is an integral part of the TPM program, that pride of ownership. Part of the training would be the detection of equipment abnormalities, such as speeds, feeds, temperature, vibration, and also odors that may be coming from a machine. And what we're really trying to do is to develop intelligent maintenance applications for these machine operators. Moving into step number 3, the work that will be performed will be done by skilled craft personnel, but supported by machine operators. So the planning and scheduling in TPM is done the same way that we plan and schedule PM orders. We utilize the PM maintenance applications, we utilize the predictive maintenance applications, but most importantly, we're utilizing the data that is coming out of machine operators. Now, moving toward page TB and continuing the list of these 5 elements, item number 4 is a key objective of TPM. It is a systematic improvement of all operations and activities. And when we get into the TPM environment, one of the byproducts of the PM program through TPM is to determine the cause of a problem if a problem was originated. That is, if it was found by the machine operator. Well, that means I have to have a network or a communication network established between the machine operator and the planner scheduler of maintenance. Don't consider a building block of networks, and let me explain that. I talk about a machine operator talking immediately to a planner scheduler. I have seen some companies indicate that the machine operator has to find a supervisor, and then the supervisor has to find a general manager, and the general manager talks to the maintenance supervisor. This is a building block. These become obstacles. What we want to do is have immediate communication between operations and the planner scheduler. Now, when you first start off, there's going to be some idiotic communication, things that don't make sense. And you have to recognize the machine operator is a nervous individual when he or she detects something that they really can't put their finger on. Irrespective of whether it's idiotic or not, look at it. Have a maintenance personnel as an integral part of PM review that particular asset based upon the machine operator's request. Praise the machine operator relative to what the findings are, whether they're good or bad. Good says there's really no major problem. We want to also take corrective action if there is some maintenance requirement relative to 4A. And then again, we want to monitor that particular activity through the PM program. And last but not least, we want to determine the return on investment of TPM. Well, major return is to increase the life cycle of that piece of equipment, just like we're trying to increase the life cycle through the predictive maintenance application. And last, we're trying to reduce the maintenance costs wherever practical. Reduce the maintenance costs through the elimination, maybe, of some unnecessary PM activities. Now, the last page in this section, page number 3, addresses some of the machine operators' functions relative to the training. Remember, earlier I said ownership of the equipment. Secondly is the inspection of the equipment. This has to be documented. That's part of the training. Lubrication is a key element. We've gone through that in PM. Cleaning, that's another major application in the TPM program. We have likewise gone through that in PM. They may perform some PM activities with PM personnel themselves, replace bearings or whatever is required, and likewise monitor the equipment or the asset performance through the program relative to recording running time versus downtime. What troubleshooting is required for the equipment or the asset to determine the cause. Changes to the process like PM is going to be changed whenever it is necessary. Change the operating method. And last but not least, there may be changes to the equipment as a byproduct of the predictive maintenance program. Now, this concludes section number 9, but let me leave you with just a couple comments. I had promised earlier in the start of this seminar that we will provide you with the roadmap to a successful PM program. I believe with the data that we're providing you, with the notebook you have, provides that roadmap. I cannot implement the PM program for you, but I could tell you hundreds of other companies have been very successful in implementing their program. There's 2 things that I would recommend you do from the standpoint of training. Everybody in the maintenance organization should be trained on page 4, section 1 of the notebook. They should understand the 9 functions in the maintenance program and the interrelationships and the integration of those functions. Also, in section 5, page 2A and 2B are some of the key data elements. Those are your starting points. I know if you put your mind to it, you can have a very successful PM program. And last but not least, what are the results of PM? There are 3. Number 1, increase utilization on a systematic basis of craft labor. 2, the reduction of inventory investment of spare parts, but most importantly, the elimination of the carrying costs. And 3rd, the increased utilization of the asset operation running time. Those 3 benefits will far more than pay for any CMMS program, the implementation of PM, PDM, and total maintenance, machine operator participation through the TPM system. And I wish you success and good luck on your PM activities.